Alright, hello everyone. Hopefully you've had a couple nice weeks. I haven't uploaded a video to YouTube in a couple weeks, mostly based on the assignments for the class. It combined two different areas, so I gave them a longer assignment. But with that, today I want to jump into, and we're in kind of the raster phase, and one of the big parts when it comes to raster analysis in ArcGIS, and when we're looking at crime, are hotspots. And that is truly a density map of crime itself. Tons of papers out there, tons of research using KDE kernel density estimations for hotspot identification. With that, there's a lot of parameters that you can choose and set within kernel density. I typically have done it in CrimeStat, free spatial stat software through NIJ. ArcPro does give you the ability to use and change up things with Python and even the parameters in here. There's some articles out there, and I'll link to one by Hart and Zandbergen on the KDE parameter selection. I've done it in the past in one of my papers. It ended up being just an appendix and a footnote, but it does shift some of what you find depending on what you're trying to do with it, more so on the smoothing and cringing part of it. But with that, before I dive into specifically the hotspot part and the kernel density part, because we'll deal with raster data at that point, I want to get into and show you another tool, another tip that you can use within GIS. So when you look at Little Rock here, I still have our crime data for 2019. I also have our block groups and streets. Have used these in other videos, nothing new there. But what I want to show you what you can create, and depending on the type of analysis you want to do, this can be beneficial in a number of capacities. But with that, I want to create a fishnet. When I say a fishnet, imagine a grid going across Little Rock with equal cell sizes across. So it's truly putting a fishnet over our boundary file. And that way it comes back as polygons, so we can attach data to it. We can split it up into smaller units of analysis. So here, even though we have block groups, and there's about 150 block groups in Little Rock, we can divide these up into much smaller cell sizes, and with that we can attach data to it, be business data, health data, social data, crime data. There's really cool micro level, and I say micro level, I believe it's about 90-meter grid cells for ambient population, so that's different than residential population, which is different from the census and connecting it to the block group or census tract level. So that you can weight it based on an ambient population side. Not going to get into that for this video, that's a bit more in depth. But for now, let's just go over how to make a fishnet, and I'll join some crime to that. So if we go into fishnet, and I typically forget where the actual tool is, so I typically search for it, and it's in data management tools. But if we just go ahead and open it, I want to specify where I want to save this, and I'm going to do it, it's already in my week 12 folder, so we're good to go there. And I'm going to put Little Rock Fishnet, and I know the grid cell size I want to use, so I'm going to do 500 feet. And I typically put a description at the end just so when I'm looking at it I know what I did without going into the properties of it. With that, this is where you have to specify your coordinate, like where you want to actually make the grid. This becomes a bit difficult if you don't have a template. Keep in mind, when I say a template, it has a default of nothing here, but if you change this and just click on the down arrow, sorry about that, you can pull up your boundary file. So this is going to bring up the X and Y extents and everything with that, so you don't have to go in and find those. With that, all I'm interested now, and this will give you a couple clues as you hover over it, the size, I want to be 500, and the height, 500. And if I put zeros in the number of rows and columns, that will maximize it for me, but since I put those in there, it's fine right now. I don't want points with these, so imagine for each grid cell, you can create label points for those. I'm not interested in that. Polyline, if I did lines, it would truly create a grid, but each one would not be individual. Polygon, each individual grid cell would be unique, so that would have a unique ID. It's separate from one another. You can display data in a different fashion that way. So I would recommend using polygon here. And with that, can hit run. Keep in mind, Little Rock's about 120 square miles. We're now dividing that into 500 by 500 foot cells. Give your computer a little bit of time. You can tell mine even though I just restarted my computer hoping that it wouldn't have too many issues. and it didn't do too bad there. So here you can tell if I change my drawing order, it went to the boundaries or the extent of my boundary file of Little Rock itself. That's the block group, but it still shows it. Now you might look at this and be like, well, it also included probably 20 to 30,000, probably even more than that, outside of Little Rock itself. So if we change these up real quick and just open this, and let's see how many cells this created. It's about 32,000 cells at 500 by 500 feet. Oh, so actually fewer than I thought. I've usually made smaller ones, I guess. So with that though, we want to select our cells that are intersecting or within Little Rock itself. So keep in mind, at this point we can do a select by location. We want to select cells that intersect or within. At this point we can do within. So we might lose some on the edges, but it's okay for what we're doing today. We want to say that they're within our boundary layer itself. So if I hit apply, you can now see the ones that are within Little Rock highlighted, and it drops down to 13,000. With that, a key part is once you select it, you want to export it out as a separate layer now. So this one's going to be, save it to the folder, go back, click on it, and there we are. And it's going to be Little Rock, Fishnet, 500 feet, clipped. And I'm just essentially saying what I'm doing. I'm not technically clipping it, but in my mind and kind of my mental notes, I know what that means, that I've selected just Little Rock itself. And once that pops up, can close out, can take off our original grid Fishnet itself. And I deleted the wrong one, of course, but I can hop back in. This is for a terrorism project. And let me go back into the courses and re-add that layer. I probably could have just hit undo. Yes, Control Z to the rescue. So there we go. Remove the full one, and now you can see when I zoom in the cells themselves. And when I say it's a smaller unit of analysis, if I bring back up the block groups, you can see now that there's many smaller grid cells within each block group. This is giving you the ability to pick up on variations, so smaller units. You can also see here what I meant on the border itself. It's fully within. You could also have done intersects, contains. You can also get the centroid and make the centroid the determining factor for us, at the center point, the XY center for each cell can be the determining factor. But now we actually have a grid for Little Rock when it comes to cells. The cool part is we also have a ton of crime data. With that, a couple just notes. For this video, I'm not going to select cells that only intersect streets. With that, say, and I'm going to turn this off and turn on the streets. Say you did end up geocoding all of your crime to street center line with no offset. It would be important then to only select your grid cells up from the fishnet that intersect streets. That's because you're only having an outcome or event that's geocoded to a street. By including more cells that don't intersect streets, you're not going to have data that's attached to them. So depending on the type of analysis or metric you want to calculate, run, you're going to have a lot of empty values that just can't actually have an event occur. So you can have false positives and a lot of other issues there. It's not fully representing the analytical ability to actually predict or understand that issue. In reality, crime could occur technically anywhere in Little Rock. But in reality, when we're address matching, it can't. So with that, we have to keep that in mind with how we're representing the data and then what we're trying to do on the next step. All right, now that was a bit tangential, but let's go forward. All right, so let's open up our crime file and let's create a subset from this. So attribute table. Oh, let's go over to our descriptions or category. Well, technically, I'm having a lot of my students this week do something with trace the gun violence archive. So to keep in line with them, let's go ahead and do something gun related. So you can see here that there are quite a few different weapon types. With that, let's go ahead and choose. I'll do firearm, handgun. There was rifle. So let's do a select by attribute, and it's going to have a couple OR statements in it. So we go to select by attribute, and I want to select from our crime layer, develop a new expression, and I want, what was that? Weapon type. Weapon type is equal to, and it will give you the drop down options here. So I'm going to do firearm. I want to add a clause. I want it to be an OR statement rather than AND, because if I used AND, it would have to be a firearm not stated, and in this case, if I'm using the same variable of weapon type, it can't be anything else. There's only one label. By doing an OR, it could be this or that. So with that, weapon type is equal to, at this one, let's hop down to handgun, add another one, similar process until we grab all of the identifiable other firearms in general. So let's do another OR, weapon type, and we have rifle, and the last one will be a shotgun. If you're not familiar with Little Rock, even though I've talked about it in many videos, Little Rock is a fairly violent city, and I did crime type and not weapon type. So the use of firearms is not surprising. Little Rock also has received gun crime intelligence support from the federal government, has recently, in the past, I think 4 or 5 years, implemented ShotSpotter. I have not evaluated that or spent much time looking at their data there, but they do have ShotSpotter. I won't get into that tangential argument of should people use it or not. But for now, we do have 1,431 crimes that included some type of firearm. So again, since these are highlighted, we want to hop over, right-click, data, export our features. And it's going to go back to the Geo database where I'm pulling all this from. This is really my base one that I use a lot of Little Rock data in. I have everything saved to the Geo database. Makes life easier for projects. With that, I'm still in my prior folder, so I'm good there. So I'm going to put Little Rock 2019 firearm related crimes. Cool. We're good there. And now I can turn off the selection here, can turn off the streets. I want to turn on the grid cells. With that, similar to before, you can change the symbology of these. So if you just wanted to do an outline so you can still see through, obviously it does look checkered, but if you zoom in, you can see where they fall with it. There is the chance if there were any along the border or edge that had a cell cut off, looking pretty good. There might be. So you can see here of why this would matter, of why you would want to do an intersect, because you do have a couple crimes that occur right on the edge, and these cells, based on how I did the selection part, was within. You want to do an intersection one there, and you would miss these, or they wouldn't be joined to it. You can see that's where I say it's always good to be familiar and play around with the data to make sure you're capturing all. An easy way to double check this is when we do the join, we'll see how many, and I'll do a join count, and we'll see the sum of it and see how many were not fully joined to it. It looks like there's probably going to be close to a dozen or so without counting each one. All right. So we have Little Rock, we have our cells, and we have our firearm related data. Now we might be interested, we just want to display these based on counts. It's kind of, and I'll show you, not drastically different from creating a hotspot map. This one just counts alone. But it doesn't look at density, it's just truly counts itself. So if we do a join, again we want to do a spatial join, and remember we want to join to our cells, so the grid cells themselves. So since we want to join data to that, we're going to right click, we're going to do a join, and we're going to do a spatial join here. And with that, we want to join our Little Rock 2019 firearm. Give it a second to load. There we are. So I want to join the firearm incidents, and I'm going to rename this one being LR Fishnet counts firearm 2019. Again, find a naming structure that works for you. Join operation. This is what it's meaning of I only want each point to go to one polygon. Each grid cell is an individual one. And I want to do it for this since I'm joining points to it. We're going to do a contains within it. So our target feature contains our points, and we should be good to go from there. So if we go ahead and okay, we could run it, but you'll see that I might as well show you a couple other tricks since we haven't done it in a while. I'm deleting out a couple of these because since we're joining, it's not as important. And since we're joining multiple ones, it's not as big of a deal for it. But with that, I might be interested in, say, even though it gives me a join count, you can also create a field and add it in if I just want to do a count and put that down there. Obviously, it's in red because it wants you to specify what's going on with it. And I'm just going to hop over there and hit count. And there we go. Count of, there we go. And here I'm just choosing any one, so it can be FID. I just want a count of how many of those there are. We have that, I specified it there, so we're okay. It's going to run for us. Remember, we had, I believe it was 1,431 firearm crimes. I'm going to hit pause. I'm going to let this run because just how many cells there are. Of course, when I say that, it already runs for us. So you can see now that it has generated. I'm going to turn off our firearm crimes. And again, another way, if you want to zoom out, you can zoom to layer. This just brings you back out to the extent. But now, since it's joined, we can right-click, open the attribute table. We have a join count, so if we do a descending part, it will show you the highest one. So the highest value is 22 in a given cell, and that's similar to what we see over here with our count feature itself that I created and just added in. If you didn't know that the join count would be there, you also have the option there. You can run other statistics with it as well. With that, if we remember, we had the about 1,431, got them backwards. So we had 1,431 original firearm crimes. If we click on this and hit statistics, it's going to give us our summary statistics, our descriptives of it, and we'll see how many we are missing from this. Hopefully it doesn't freeze on me. I actually had Arc Pro crash on me for the first time last week. And there you can see that we had 1431 originally, so we're missing 17. Max is 22, plenty of zeros. We barely have a mean of over 1. So you can even see here that we have a highly curtic and skewed. Obviously, this would be appropriate to do kind of a count-based model, something with that. But we also have a lot of cells in here that, honestly, even with 13,000, we'd probably still take out another 4,000 that can't actually have crime occur in them. But for now, based on what we're doing, we don't need to do much with it. But cool. So we have this. Let's get into the symbology part. So you can actually, and we'll get into, and I'll keep this layer, and we'll see how this looks. Oops, wrong one. So we want to do it based on a graduated color. If you ever see this, this is where Arc Pro has a default set to 10,000. We have over 10,000 with it. And when I say that, we have grid cells over 10,000. So to get around that, where is it? Advanced Symbology, sample size. And I just add on another 0, make it 100,000. Now we can display everything. Not a big deal. That's just understanding if you see that warning, it's your sample size aspect to it. Let's hop back over to our symbology part. It has join count up there. I'm okay with that for now. With it though, natural breaks, given our data set, I'm not a huge fan of. If we did equal interval, it's not a great way to display the data either. We can do quantile, and for this, we're going to have a ton of zeros. So this is breaking it up into 20 percentiles. With that, I'm really only interested in, let's say, our high ones here. So we could go in, and I didn't really mean to do that. Go back. I guess, yeah. I did mean to do that. I was going to change just the color scheme, but since we're in here, let's just go ahead and do, for our lower ones, a no color and no outline part to it. So you can start to see now where some of our higher regions are. So these took out all the zeros. So you can see we have far fewer cells that actually have values within them. An easy way to double check that and kind of just see is if we went back and just did a quick select by attribute. We want to choose from our firearm a new expression. We want to do join count is equal to or greater to 1. Hit apply. We're going to see all those highlight. Open the attribute table real quick, and we see that 560 cells actually had more than one or more, sorry. So a small subset of that. And you can see there are some clusters formed. And if you're familiar with our prior videos in Little Rock, we've done some other types of videos based on tracks and block groups. And this is where I say variation matters greatly depending on the unit of analysis that you're looking at. So you can have a high block group, a high census tract, but when you delve down into it a bit more, and you could do this at the street segment level. So I've joined some of this crime data before to streets. You can see certain streets are high. This is just another way to visualize the data itself. But you can see within any, I'm just going to make the boundaries a bit larger just so we can tell in some of these areas. There we go. Thicker, wider. There we go. So when we zoom in, we can see that even though, and I'm familiar with Little Rock in these areas in particular, then down here as well, often coming back as our higher rates and counts across crime types, not just firearm itself. But with it, you can see that a lot of these areas, even within specific neighborhoods of our block groups, don't have any. And it's really coming down to a few blocks, street segments that are contributing to the higher counts as a whole, which depending on the neighborhood population can increase the rates to a certain extent as well. So keep in mind variation exists at many units from a hot point or address, and if you haven't heard of that, read up from Ratcliffe's Hotspot Matrix. I think it was 04 or 07, one of those years. Good article that discusses the different types of temporal, spatial aspects that people should pay attention to. But you can see this variation across a lot of our different neighborhoods. Some have none related or no firearm-related crimes from 2019. Some of these have a lot. And that's where we say crime's not random, it's not uniform, it's not equally spatially distributed. If so, the 1,431 firearm crimes would have occurred in 1,431 different cells. We saw that they didn't. There was a reduction of it. We missed out on the 17 that were outside of the boundary. But if we assume spatial equality, they would have been at least one per cell to some extent, or randomness to some of that. We haven't assessed statistically if this is different from random, but if we also did the average nearest neighbor based on our point data, and we've already done that before in another video, we would likely find that this is clustered based on what's observed versus expected, so no shocks there. So at face value, this is a quick way to do a count, join to a grid, and how to make the grid. Oftentimes nowadays people make a grid cell size based on the average block length. You can do it that way. You can go to even smaller units. A very common thing to do now is attaching everything to a street segment based on how much data is joined to that. In some capacities, especially with our cells, you can get into an issue of intersections and how cells fall, can integrate and fall across. So street segments or blocks are becoming the norm, but cells still have a lot of value with it, especially when you want to do map algebra. Super easy. And when I say map algebra, and this is going to date myself probably a little bit, if you think about overhead projectors and the sheets that you put on, you can layer and layer and layer and layer them on one another and still see the image as you put more on. Imagine doing that with grids. So when you have data attached to the grids, you can keep layering on and do different mathematics and statistics with it based on the grid layers itself. We're not going to get into that here, but Tobler gets into that as well, so if that's of interest in that Tobler's law. I'm blanking on something else, but again, really just comes into map algebra. But now let's turn these off, and we'll do a simple comparison here in a bit. Let's just do a kernel density estimate of the same data. Alright, so let's hop over to our geoprocessing. We just have to go back because it's still in the Fishnet creating part. Go back again. Now we're in our toolboxes. If we scroll down to the bottom, if we get into our spatial analyst tools, we have density, which is what we want to essentially do. And we have a couple different ones, and I'll link to this kernel density one. You have the options on the website to click on the other ones if you want to learn a bit more. But for now, let's get into kernel density. So with that, we want to input our point. You could also use lines, but we have our points. Little Rock firearm crime population field. We don't have one right now. And that's where I say you could use a population such as the ambient one, which I'll make a video at a certain point. I just want to become more familiar with the newer ambient population data myself. So I'm going to do KDE Little Rock 2019 firearm. Hit save, and yep. So if you ever see this, it probably has too many characters. Yep, and that's the issue. So go back in, and I'm just going to do KDE firearm. There we go. Cell size, and this is where it's giving you a default one now. I'm going to make it the 500 to make it similar to the Fishnet that we already created. Search radius, so this is where it's going to do the density part, how far out it's going to search for it. So typically, if you're doing it based on your block size, you'd want it to search 3 to 4 blocks out from a routine activities perspective. So with that, I'm going to keep my cell size at 500 and do a search radius of 1500 for now. So it's going to be relatively small. And I'll say this because if you read and look at the article that I'll link to for Hart, it gets into how parameters matter for this. So for now, I'm not going to get into it too much, but I'm going to put 1500 here, so 3 times around. With that, you can choose your output units, square miles, square feet. For us, these are going to be small all around. If I do our part here, our map units are in feet already, so we're fine there. But I'm going to choose square feet. We're interested in, and this is where it will give you a couple different options, expected counts. And I'm not going to get into the whole difference now of expected counts and densities. It gives you those definitions in the walkthrough in the website alone. But essentially, the expected count is the density times the area kind of thing. But for now, we're okay. And we just want to do our density. Our method is defaulted to planar, which is fine since it's much more of a local projected part to it, so we're good there. Barrier features, this is different than I've used before, so let's hover over it. Barriers within our data set, but for now, we're okay. You can always, and this is where I always set the extent when it comes to kernel density and ArcGIS, just out of habits of, if we turn on our crime real quick, you see our highest and lowest points, and it still might do it to where it would only run kind of a box around this, but I actually want the box around the entire part of Little Rock. So the processing extent, I hop in and just go and set the boundary. This is what I've kind of just gotten in the habit of doing over the years. But with that, let's hit run. And there we go, and we can pull this up. And you can see here where it's starting to show, and I'm going to turn off the values here. And you can see the darker it gets, and this was in squared feet, so that's why they look so small. The darker it is, the more densely populated that is. So if I open the attribute table, so key part with raster data, you have to actually convert it back to get to it. So raster data are different from polygon. Obviously, that's talked about in the book. But with that, if you wanted to change this, so you have an output. We know our hotspots, so you can see they're here with purple. We can still change the symbology and everything with it. If you wanted to do a different color spectrum, I was trying to find a red one. Where'd it go? is. I'm just going to flip it if it lets me. Reverse the order. It's actually not letting me do that. But for our bottom one here, I'm just going to hit no color. You can see we have our hotspot map. And I'm going to show you here in a second how to export out of raster into a polygon file. But now if we turn these off and on, you can kind of see now what it's doing differently. Even though there's crimes occurring elsewhere, they're not densely populated in certain areas, so you have standalone ones. What kernel density is using the search radius to check how many, essentially grab those crimes around and understand how densely populated that area is to that one cell. So all the cells surrounding it, how many are there within 1,500 feet, and from that, how densely populated based on the area is it? So with that, you can see that this lines up to what we could guess if I were to ask, all right, where would you think high density clusters would be? You would probably guess a lot of these. So we'd be in good shape here. So with that, kernel density, and this is a quick way to display the data, is what you often see. And this, when I say a hotspot map, this is what I tell people if I change this to have, say, a green part too. Where's that one at? What people think of almost as a weather map. There we go. Red's bad, storm's coming. Yellow's still bad, but not as bad. And as it goes down to green, yes, there's potential, but not as much. No color, you're in the clear for the most part. Rarity does exist, but this is how, if you look at it, weather map is what comes to mind when a lot of people look at it. Red, bad. Green, blue is your cooler colors, not as bad with it. And you can see here it's set to equal intervals, which makes it better for this, So 10. Now with that, what I mentioned with this is we run into the issue with raster data, the ability to manipulate it. So we have our density values here, which are great, but how do we manipulate those and how do we use those? So if we come back up into here and go to our data management, we want to, why am I blanking on it? Because it's not data management, it's conversion from raster. So when I do from raster to point, you can do polygons, but I typically do point then to polygon because it will give you the centroid, and then you can join your centroid to another fishnet layer. But this is where you would go and transfer it. If you wanted to do raster to polygon, you just input your raster, our firearm 1, our value field, I'm not sure why it's giving me that error. Give me 1 second. All right, let's try this, and I want to troubleshoot kind of on the fly. So what I want to do, I'm going to make a similar KDE, but I want to change up one part to it. So population's fine. I don't have anything that I want to use as my population base. I don't want it to save. That might be the issue of where I'm saving it. So let's do that. I'll keep it, this is going to my geo database instead of a folder. So 500 foot, 1500. Density I want to keep, I'm just going to keep it a square mile now. Keep in mind, I'm going to go in and change my environment to be the boundary. Hop back over. So keep in mind that this is saving to a geo database rather than my folder. Let's see here. It's going to generate that. Cool, we have the same map, higher value so you can do more with it now. But now let's take a look. And if I go back here, scroll up, I have a raster and I want to do raster to polygon. And it's still giving me the same error codes. So maybe that's my fault of not understanding why I won't go to polygon, but it will do a point for us. So you could take the points, and since we already have If I turn this off, our grid here, you could do a grid afterwards. So if we have our KDE Raster output, it's going to save there, which I'm fine with. If I just hit run, we now have all of our points, again, similar to the same issue we had when we first did the grid. Now we have points everywhere. If you zoom in though, they are dead center as centroids for our individual cells because the extent layers for both of them were set to the boundary of Little Rock and we use the same cell sizes. So at this point, all you would have to do is do another spatial join, and you would have the grid cells with your density values with them. And if you go to your attribute table, your value itself, so let me sort descending. Keep in mind, this is the one that I did originally in square feet. So you're seeing these values here that are the red to green spectrum versus the purple ones. So the higher it is, the more densely populated it is. You can see, and I'll just highlight a couple and then zoom out. And you can see where those were originally located, and those are the areas that come back with it. So with that, I apologize about the end part trying to do polygon, but it's point, then you can take your points and go to and attach to your grid cells, and you're good to go there. With it, we went over how to make a fishnet, how to join crime data to that, how to do a select by attribute based on multiple weapon types with OR statements. Also went over a very quick way to run a kernel density, a hotspot tool, of how densely populated is a point item, or you can use it with lines. Within your study area, you can specify, you can change the parameters from cell size to search radius. Like I said, there's articles out there that spend time going into that and testing it depending on what you want to do, what matters more so than others. With it, if there's any questions that come up, interest for it, let me know. In the future, and I say that probably over the summer, I will get into the ambient population data and how to use that, because population does matter. And when we think about risk and victimization and everything with that, you have to have two parties, an offender and a potential target, a victim. So how those join in space and time matter. So you need to understand how people move in ambient populations one way. I won't go on my tangent about Twitter data, but we'll get into that another day. If there's any questions, please reach out to me. But like I always say, experiment with your data, especially when it comes to kernel density maps. You can do it a number of different ways, display it different ways. A good way to typically break down your values is based on the mean and standard deviation. So what areas are plus minus one standard deviation from the mean. You have your high and lows, but since we're really only interested in our high crime areas, so what's the top 10%, what's the top 20%, that's probably going to give you more than the standard deviations because our mean values typically going to be super low, but that's where you have to play around with your data. Understand it, look at what it's displaying, what story are you trying to tell with it, and if there's any questions, please reach out. Take care.